Are we live? Let's see. Yeah, it seems like we're here. All right. So welcome everyone, if anyone is watching. This is gonna be the third part. I imagine we're gonna go on for about an hour today or so. Just a heads up, my neighbors have been making a bit of noise this evening, so our scuffed stream may be a little bit more scuffed than usual, but it should be alright. What we're gonna do today, I was thinking we were gonna do some movement code, but I think we should actually go ahead and do some animation stuff first. Some very simple animation codes. We're gonna set up the sort of skeleton for the animation handler, and we're gonna be combining that with the movement, so we can start incorporating animation code and physics right away. That's gonna make things a lot easier on us in the long run, I think. So let's see, let's review what we have. We have made so last time we just went over the concept, what we're gonna be working towards. And the first time we made a tilemap loader and a hitbox loader. And there's not a whole lot more that you need to make a functional sprite. So I guess we're just gonna go ahead with the basics of the animation handler. So when we made this tilemap loader, we made it load a tilemap from a pointer, and the pointer is supposed to point to a tilemap with this format. There's a 1 byte header that tells you how many bytes are going to be in the tilemap. So for 3 tiles here, we see that we have C, as in 12. You could also do this if you want, but I prefer hex. And then it will load all of these. The tilemap loader and the hitbox loader both take sprite facing into account. So if it faces right is direction 0, but all the graphics face left by default. So all the tilemaps and hitboxes are based on the sprite facing left. So they get flipped if the sprite is facing right. But what we're gonna do is we're gonna set up a few test tilemaps instead of just this one here, and we're gonna set up an animation handler for swapping between them. We're also gonna leave some room for the dynamic graphics that we are no doubt going to have to incorporate at some point. Even though we don't have them yet, we're just gonna leave room so we can easily incorporate them later. That's the plan for now, at least. So what do we need here for graphics or for animation? The only thing we really need is some sort of system that lets us link animation frames pretty easily. And the way we're gonna do this is we're gonna have a big old table, probably here. We're gonna call it anim or animation. I usually just call these anim because I think it's fast. It's faster to write. So that's what we're gonna do. And we are going to have a format for each frame. And it's going to be something like this. We're gonna store a pointer to the tilemap. We need how many frames to display this frame. And this can get a little bit confusing because frame refers to 2 different things here. So let's say how many frames to display this tilemap instead, because here frames means, you know, it's a measurement of time, and here frame here used to mean like which animation frame. So how many frames we display this tilemap, and then we also want to know which is the next tilemap. These are the main things we need to know. If we do incorporate dynamic graphics, we also need dynamic graphics to load. Let's put parentheses on this because we don't have any graphics to load currently. So yeah, let's put it like that. So we're gonna leave room for this, but we're not actually going to code this function yet. And so you can see here, the pointer to the tile map, that has to be 2 bytes. So let's try here, test TM. So 2 bytes, right? Then we need some sort of data for the dynamic graphics. We are probably gonna need 2 bytes for this as well. Maybe 1 is enough, I don't know, but I would rather reserve 2 bytes for it currently, because otherwise we're gonna have to expand it later, and it's always easier to, well, cut something out than to add something in. That's not actually a hard rule, so forget I said that, but we're gonna leave it at 2 bytes for now. So we'll just put a 0 here, 2 bytes 0. This is gonna be data we later use for dynamic graphics. And then how many frames to display this tile map? That really only has to be 1 byte, and we are going to need 2 more sprite regs for this. One that is a timer for the animations, and one that keeps track of which animation is currently being displayed. So we'll add 2 more bytes here. How many frames to display this tile map? Let's put it at 8 frames, and then the next tile map is going to be entry 1. So this is entry 0, and then let's make entry 1. And this one will, let's see here, test tile map 1, test tile map 2. And this one will go to animation 0. So this is entry 0 and entry 1. So what we want to happen is that the system will read this. It will be it will have some sort of register, sprite register, that says, okay, we're on animation 0, so we load this tile map and we increment the timer, like how many frames we have been showing this animation, or how many frames we have been showing this tile map. And once we reach this number, we read this value, and we set the animation index to that, and then we clear the timer. So we'll go to this one for 8 frames, then this one for 8 frames, this one for 8 frames, because you can see here these two loop to each other. This one is number 0 goes to 1, and number 1 goes to 0. And we're also gonna need, I said here that we have test TM1 and 2, but we only actually have this one, so we're gonna call this one test TM1. And let's actually just make this the Koopa. So let's remove this tile, and let's make another copy of this. Let's make sure we have the right tiles here. This is 82 and C2, that's these, right? So this one is gonna be 82 and CO. Actually, this one should be CO, right? And I think this one is supposed to be 1 pixel higher up during things, so we'll set the Y offset to -1. So we have this, and let's add some new sprite regs up here. So we need anim, let's call it anim index and anim timer. And now we're gonna have to check in the, where could it be here? Right, SA1def. We're gonna have to check for a table we can use. I'm also gonna open the Super Mario World RAM map on my other monitor to get some more information about these. So let's see, 1504, are we using that one? We are. 1510, are we using that one? We are not. So let's look up 1510, what is that one used for? Miscellaneous sprite table. In the original game, it's only used in the revolving brown platform and nowhere else. Unlike 1504 and many other sprite table, it is also not cleared by the sprite table initialization routine. Okay, so we can definitely use this one, but apparently this one has an exception, so we need to clear it. So I guess we are actually putting something in our init routine. So this is something we're putting here just because we're using specifically this one. So let's see, let's get this, let's just call that. And this is going to be anim index, and this is one we have to make sure that this is a sprite table that does not automatically decrement. That would be really obnoxious. See the next one, 15.1c, because I said we need 2, right? So that's gonna be this one. I don't think we're not using it, and I think this one is safe to use as well. Miscellaneous sprite table in Submerwell is used for vertical directions, and we are not using vertical directions for our sprites, so this is fine to have. Also used by Reznor. Let's see, and used by Yoshi. Yeah, so we can use this one as well. So we have anim index and anim timer. So let's go here. So before graphics, we are actually going to put something else, and we're going to call this routine animation. I guess we should move this comment to below animation, because that's only for graphics. So we have, also this makes sense here, right, that we're calling this table anim now, and this is just, and this is going to be the animation code. This is where we put all the code to change which tile map we're gonna pass to graphics. So what we do here is we're gonna put some simple code here for updating, for like automatically handling this, and then we're gonna have a lot of exceptions that other codes can use to update this outside of the like simple rules we set up. So we're gonna have, let's see here, anim timer, and I would prefer for this to increment rather than decrement. I think that is for me that just makes more sense for animations. I'm not really sure why. You can definitely make this decrement if you want. It's really no problem. But I'm gonna have it increment. If you code something like this and you have a decrement, no worries, you can do whatever. We increment it, and then we need to compare it to something, right? So we compare to anim, and then we want to index by something. And how do we get this index? So we put 1, 2, 3, 4, 5, 6 bytes in each entry. So we want to index this with anim index times 6. So here we get anim index. Let's see, let's just dump it in, actually I just had an idea. This is gonna be a boss with a lot of different animations and a lot of different tile maps and frames, so we might actually run out of index space, or like our index might not reach far enough if you use 8-bit mode. So we're actually gonna go into 16-bit mode right away here, and we go allreg 16-bit, and then we load this. We get only 1 byte because we can still only have 256 different animations, but and then you might wonder, okay, then why does it matter that we might run out of space on an 8-bit index? And that's because we're gonna multiply it by 6. So let's just dump it in 0, double it, we add the 0. We don't have to worry about the carry being set here because we cleared the high byte and then used ASLA, which always clears the carry. So here we multiply by 2, add the first value, so now it's multiplied by 3, we multiply it by 2 again, and now it's multiplied by 6. And now we get this into Y. Now we go 8-bit A. Let's just make sure we remember to have all regs 8-bit again at the end. So now Y is the index to whichever frame we're currently supposed to display. So now we can get the pointer to the tile map. So now we can get this value right here. And what we're gonna do is we're gonna index, we're gonna compare this to anim plus whatever the offset of this value is. So plus 0 would read the tile map pointer, plus 2 would read whatever data we have for the dynamic graphics, and plus 4 will read this value right here. So we're going to compare to anim plus 4, index Y, and if it's different, it's still the same animation. We should still be on the same animation, so we just store back anim timer. So we loaded it here, incremented it by 1, we compared it, nothing should be updated yet, so we just store it back after it's been incremented, and then we go here. And if it's not, if we're not on the same animation, we should, we have to update this in some way. So we load the next value here. I'm being a bit distracted by my voice. I still have a bit of a cold, so I feel like I sound very strange. If anyone's watching, you probably can't tell, you don't know what I normally sound like, but I feel really weird. Let's see here. So we get this value, and we just repeat this math we had here. So we just copy this really. And let's see, so we read this is gonna be the next animation index. So we just store this to anim index right away. Then we get this multiplied by 6, get it into y, and then we load, let's see, here you can see we store to anim timer, so we just load 0 here to make sure it starts at 0 on the next cycle. And now here, when we're going into graphics, we always have y equal to the index to whatever tilemap pointer we want. Or y is the I don't really know what to call these, animation entries, I guess. Yeah, I call them entry here. So y is always the index to the to this table here, pointing to the currently active animation entry. So where do we have it here? Instead of this, we are going to load anim plus 0. I like to specify plus 0 here to make sure that it's clear that we want to read the first 2 bytes. And that should be, oh right, here we're actually setting we're setting the index back to 8-bit here. That's no good. We have to remove this, and here we can set it back to 8-bit, right? Yes, because this is just the tilemap loader. And here we already have gotten the tilemap. Maybe we should actually set the tilemap here, and this is just the loader based on whatever is stored to 4. I kind of like that more, actually. So here we do like so, and then here we can actually go back to all regs 8-bit mode. That should be good. Now, let's see if this actually works. I said in a previous part that the most likely outcome when you just write some new code and you're testing it is that it crashes. So let's see if that actually happens. What did I call make is what I called it, right? Okay, let's see what happens. It's not doing what I was hoping it would do, but it's clearly animating. So we did something right. I'm guessing I just wrote the time lapse incorrectly, and that would be correct. You can see here that the X offsets are not supposed to be minus anything, they're just supposed to be 0. And these tile numbers, I'm guessing they're incorrect. Let's see, what do we have? We have 82, and this is not 82, it is. And we have CO, oh right, it's supposed to be AO and A2. Now let's make it again. And we can see that it's not quite right. Which, wait, why is it wrong this time? Oh right, I didn't actually distinguish these. Yeah, so much for being careful, right? So now these time lapse should be correct. This time I actually set the X and Y displacements properly. So let's make it one more time. And here we go. So this is how easy it is to make animations with a system like this. And we can very easily link more tile maps to this animation. This is how it looks currently. And we got no crashes, which is a good sign. But as you can clearly see, this thing not moving. It ain't moving. It's just stuck in midair, and it still has our like placeholder interaction here. We still have this debug code here. I think we're gonna get rid of this. We don't need to test if the sprite can X-flip anymore because we tested that last time. We're gonna keep the debug label though. I'm sure we're gonna add more debug code later at some point. So let's see, now that we have this, we are gonna go ahead and write some physics code. And I like to put this before the hitbox. As you can see here, the order of my code is pretty weird compared to normal Super Mario World stuff, but I think this is appropriate for a boss character. So what I like to do is decrement all the timers that are supposed to be part of the normally this is done before the sprite is even called, so this is only for the like timers we use that are not part of the normally decrementing sprite registers. Then we do physics here to update where the boss is in the level, and then we call the hitbox routine after the boss has moved, so that this actually matches the most recent position the boss has. And then we do animation code, then we actually draw the boss on the screen. And this makes sure that the graphics always match where the boss is on this frame, pixel perfect. In a lot of Super Mario World sprites, not just Super Mario World, in a lot of Nintendo games actually, the graphics are called first in some sprites, but not others. And that makes it so that sometimes objects are actually drawn like one frame late. Like they in the game's logic, they exist one frame further in time, if that makes sense. So they're like 16, they're drawn on the screen where they were 16 milliseconds ago instead of where they are now. Does that make any sense? Anyway, that sort of bothers me, and for the purposes of this, what am I saying? And because of that, I like to do it in this order. This is sort of janky in Super Mario World because the majority of sprites are drawn first, then moved. So it's only really for a boss character that I would advise you to do this, because there aren't gonna be very many sprites on screen, so there's no real like... it's all gonna look cohesive anyway. So, let's keep going. Let's go with the physics. And the first thing we're gonna do is we're gonna hook this up to the main update position code Super Mario World makes use of. This routine is actually pretty good. Handles all the stuff we want it to handle. We're gonna make use of it for at least phase 3, which I said we were gonna code first, which sounds strange, but it's gonna be the easiest one to do. Update I'm trying to find the routine sprites. Here, subroutine that updates the sprite's XY position, including gravity and block interaction. And it's this. Let's see, we're gonna add this here, routines. Apply speed. There. Let's see, we're actually not writing this in hybrid format. I guess we should add that. Let's see here, physics and JSL apply speed. Let's see, where is it you add? You add like bank B, right? Is that correct? ASM, it should be here. Bank B. Bank B this, bank B that. Yeah, I think bank A. Okay, so bank A is for RAM, bank B is for ROM. Or you can just do bank. Let's see, what else do we have? We have DP and address. So I guess we'll do, we'll use bank B here, because I think that we might actually use the 7E and 7F banks at some point. So we want to specify that this is actually a ROM bank. So let's add this here as well. And then here we just add address. I don't like base 1, base 2 because address and DP is a lot more clear. So now this should be hybrid format, right? Am I missing something? I don't think so. So let's see, physics. This also updates the sprite's collision registers. So let's make sure we add those as well, because we probably don't want to use these defines because they're really clunky. So let's see here. Yeah, as you can see, sprite blocked status. So status, I don't know. I don't have an English accent. It's just how I talk. So we want this, and we want to call it something else. Let's just call it blocked. And we are going, what we're gonna do is we're just gonna call this will include gravity, so the sprite is going to gain 3 speed units down every frame it's in the air, and this actually applies while it's on the ground as well, so we're just gonna make sure that doesn't happen. So blocked, let's check the ground bit, which is 4, air, let's just differentiate these here, ground. And if it's on the ground, we are, let's see, what you're actually supposed to do is you set the Y speed, right? Now we have to add those as well. So let's see here, sprite, speed Y, kind of like that, but Y speed is shorter. Let's see, right, XY order low. No, wait, that's Y speed. I like to put X first, even though Y is actually first in memory. This just makes more sense to me. Let's see. All right. Very based. Very based runic. Yeah, I guess that's true. There are a lot of shared codes in Super Mario World. It's important to keep in mind that it's a half megabyte ROM, so the code is, a lot of people might call it spaghetti code, and it kind of is, but it sort of has to be for it to be as small as it is. A lot of codes are shared in Super Mario World. Let's see. Oh yeah, the point about that, you can still call the graphics routine and then just update the tile number afterwards, tile number and property afterwards, but you could still have movement before. Now that I think about it, I'm not really sure why they do it in the order they do, but it is what it is. If we do run into any problems, we can easily change it to, we can change our sprite here to have graphics first. But for now we'll proceed with it this way. Anyway, we're setting the speed here, the Y speed, to 10. And the way these units work is that the upper digit here, the high nibble, that's pixels per frame, and this is sub-pixels per frame. And as you can tell, this goes up to from 0 to F, so there are 16 sub-pixels in each pixel. And what this does is that every frame, it makes sure that while the sprite is on the ground, it doesn't like keep gaining speed from gravity, but gravity will, or its Y speed will be set to 16. And this means that every frame it tries to move 1 pixel down, and it keeps hitting the ground, and that makes sure that it keeps updating this flag right here, that it's on the ground. And this is gonna be important. Anyway, we hooked this up, so let's test it. Wait, let's see. Yeah, it falls down. And if it did like walk off something, we would see that the speed is actually reset to 1 pixel per frame down. So, well, all of this went really easy, real smooth. I don't really know what we're gonna do right now, so I'm gonna look at our design document again to refresh my mind. See, here it is. Putting this here so you can see as well. We are gonna do this right. We're probably not gonna do the projectile right now. That will be a bit more complicated than what we can do in half an hour, I think. So let's make these 2 moves happen. Maybe this one as well. So to do this, we need to make sure the sprite can move horizontally, and we need to make sure it can actually run at the player. Let's see. We might want some special code in the air compared to on the ground. I'm thinking how much we should incorporate different animations right now, because no, I think we're actually not going to incorporate a lot of animations. So let's add above physics. Let's keep physics like very simple and clean, and above we just add an attack label. This is going to be the attack code for this phase. Later on we might have when we have, I'm not sure how we're gonna structure this when we have multiple phases. We're probably gonna have multiple attack labels. We'll see how we do it. But first, let's make sure we add another sprite reg up here. We are going to have probably just the next one in line here, honestly. I think 1528 is usually free. 1528, miscellaneous sprite table. Instrumental is used for charging chuck HP. Yeah, we disable fireball HP in the JSON file, so this is gonna be fine. Let's call it, just call it attack, why not? Keep it simple. Like that. And these are of course automatically adjusted based on SA1, so this is hybrid format. Always code in hybrid format if you can help it, folks. And here we're gonna add a simple pointer code. So let's see. I'm actually gonna add something else up here, and it's, I think it's 15E9. Yes. Sprite index. 15E9 address. What this is, it's just a faster way of getting back the sprite index if you use it for something else. Instead of pushing and pulling X, this is a lot more convenient. It's actually faster, and you don't have to worry about stack order or anything. So what we're gonna do here is we load attack, we double it, we get into X, and we jump into the pointer here that we're gonna have. We don't have a pointer yet, I'm gonna make it right now. So let's see. Here we are shredding X, so keep that in mind. We are losing the sprite index when we do this, and this is why we're gonna have to get it back with this code here, sprite index. So here, these are going to be pointers to all the different attack codes, and let's start with the ones we were gonna just start with. Bomb rush is gonna be the first attack, then the next one is gonna be pounce. Let's just start with that. Right, we also have to return somewhere after this, so let's make sure we push a return address here. Where do we go? We just go to physics. This is sort of weird that you have to add -1 when you're pushing an address like this. It's just how it is. So this command will push the address of physics, and if we add -1, that will make it an RTS address. So these codes, bomb rush and pounce, all the attack codes are gonna start with the LDX sprite index to get this back, and they're gonna end with RTS, and that will cause the program counter to go to this label here, physics. Pounce, it's gonna be the same thing here. We get these, and then we put all the codes, or we put all the code in between here, right? So, one thing I really like to do with these pointer codes, I think this is a really neat optimization. So you can see here, we're in 8-bit mode, we're loading this attack, and we're doubling it. That means that whatever is in the highest bit in this register is going into the carry, and it's not gonna be a part of this value here, because these are 2 bytes wide. So we can actually only have 128 entries, meaning that the highest bit is unused. So I like to use that as a flag, as a sort of init flag. So for example here, bomb rush. We want the... hello Anon, welcome to the stream. We're just coding bosses, as we always do. And so what we're gonna do here, we want the sprite to like pick a direction at the start of the move and start running in that direction. we don't want it to like keep spazzing back and forth if Mario jumps over it. So what we're gonna do is we're gonna use the highest bit in this attack register as a flag for just having initialized this attack. So we at the start we do this attack, and if it's negative we go to main, otherwise we have init here, and we do this. So, and this is some simple code we can just copy paste to all of these if we want anything to run only on the first frame of the attack being active. And here we are going to make it pick a direction, probably the direction that is towards the player. So I guess this is the, I think there's a function for this in Pixie, the sub horse pos function. Let's see, routines, sub horse pos. What's the input? None. Output y equal to, yeah, whatever. Caution, some sprites use a version of this routine where only f is being stored to as the low byte of the distance. I don't think we have to care about that. Let's just use this as normal. Is that how you do it, or is it? No, it's capitalized. Sub horse pos. And this is how you do that. So now the sprite will face, on the first frame that this attack becomes active, the sprite will face the player. Awesome. And then I guess we needed to actually have some speed. And at the start I think we're just gonna put the X speed here. And we're gonna make it really simple. Let's see, direction 0 was right, if I recall correctly. So let's have it run at this speed. This is slower than Mario's max run speed, but it's faster than his walk speed by quite a bit. And then we load the direction in main, we load X speed, and we put it in the sprite reg for X speed here. That should do. And I actually like to have no distance here. I think I said that in a previous part. Like, I usually like to have no distance between these. That's why I put the that's why I put my sub labels in this column here. They sort of act as comments and labels at the same time, so it's easy for me to see. The colors help a lot too. So. But I think I also said that it's probably easier for you guys to see if I do this. So. We'll keep some distance here. We'll socially distance our code. We're also gonna add a. I'm thinking out loud, but my thoughts are pretty disorganized, so I think what I'm saying doesn't make a lot of sense. So I'm just gonna be quiet for a few seconds and think. Yeah. I think what we need now is let's see. We're not actually setting attack to anything, so we're never gonna reset this. So if we run it right now, the boss will just start running towards the player, and then we'll just keep running in that direction forever. So we need some sort of timer or something else to reset the attack. Is it hard to see my code on stream? I think I watched the first episode back and it looked fine for me, but maybe it's difficult to see. Maybe the quality is different today, I don't know. Let's see here. Oh, I keep using turbo mode. Let's see, so it's just, yeah, it's just gonna start running, and it's never gonna stop running. It just keeps on coming. Let's see. So it's hard to see, eh? How does it look? Oh, right. Oh, right. Is this actually how it looks for you guys in my preview here? Okay, I can see just fine if I set it to the highest quality and full screen. Then it looks just fine. Maybe that looks better in the VOD than it does live. I don't know. I don't know what I can do about that. I'll try to figure that out for a future part if necessary, but I don't think I can do anything about it right now. Let's see, how much time do we have left? We have 20 minutes. So yeah, we can finish this attack setup at least. So let's add a timer for the attack. We're actually gonna use my favorite sprite register for this, 1540. This is a, I call this the generic timer. Let's see, attack timer. And it's a register that just, the only thing it does that's special about it is that it decrements itself once every frame before the sprite code is called. So it's very convenient to use. We're gonna use this for the attack timer. Let's add a space here to make sure we remember that there is another sprite register in between these. Or we don't do that because we want the attack and attack timer defines to be next to each other. I don't really know how to order these. Let's see, refresh the music there. Alright, so what we're gonna do now is here in attack, I guess we'll do this attack timer. If it's non-zero, we just process this. And if it is 0, we let's see, we can't use the frame counter because that will make this actually a non-random. So let's see, how do you get a random number in Super Mario World? I can't remember. What do you mean by a diagram, Anon? I could do a diagram of what the boss should do. Oh, I see. Yeah, one of these, the ones that programmers always use with these like boxes and arrows that point to each other, right? Random. This. So how does this work? Input A, max value. Output A is a random number in that interval. Yeah, that seems fine. I don't actually know how this works, but we're gonna use it. I know I've used this before at some point. So A equal to, we have 2 attacks, right? Does that mean I should load 2 or 1? Can it load 0? It said 0 to A, right? So we're gonna load 1 and random. So now that's a random value, right? Store that to attack. Let's see, pounds doesn't actually do anything. So if the boss rolls pounds, it should stop. Actually, let's see, it doesn't actually update the X speed automatically, so I guess we'll have to, just to make sure. Yeah, okay, in the next part we'll make a block diagram to make sure this, this whole project makes sense. Let's see, and now if we should be able to tell what the boss rolls at least, so we should be able to see if the attack system and RNG works. Wait, oh right, I'm not actually setting the attack timer, am I? Let's see here. Store to attack. Let's put like 1 second in the attack timer. So every second it will re-roll. Let's see. Yes, I am using a custom Notepad++ color scheme. It's based, it's loosely based on the default Obsidian one, I think it's called. Let's see what the boss does. He stops and he rolls charge. I didn't call it charge. Yeah. Now he's rolling that a lot of times in a row. Okay, so here we're immediately... So what I'm worrying about here is that sometimes this guy will roll the same move a lot of times in a row, and that's sort of annoying. We probably want to add some sort of RNG control. You see here, he's standing still for so long. He's just rolling the same attack, and that's no good. I don't like that. So we're actually gonna add another define right away. Thank you very much, Adam. I appreciate it. It's so weird to actually talk to chat. How do streamers do this? This is really fun, but it feels so weird. I guess you get used to it. Let's see, 1534 is the next one. I think this one can be used as well, right? This one does not decrement automatically, does it? Miscellaneous sprite table. It doesn't say it's a timer. Alright, so we just Gonna use this one. Attack timer. There. Notepad++ sometimes glitches out for me and like makes something be the wrong color until I refresh it. I don't know why. I got the streaming bug. What's the streaming bug? Yeah, so I know in Visual Studio or VS Code, I don't actually know what that is. I'm guessing it's... I shouldn't assume, I guess. I thought that was some sort of Visual Studio thing. But I don't actually like autocomplete at all. It just really annoys me. I think it is... I think it's probably optimal, but I really dislike it, so I stick to my guns and use Notepad++ anyway. Alright, a disease where one must stream to satisfy. Yeah, I don't really know what that means. I'm just doing this for fun, really. I've seen enough streamers to guess that it would be something I enjoy, I guess. So I wanted to try it, and I think this can actually be useful for people. Hopefully, it can at least. So what I was gonna do here, I added a new register here. Attack timer. No, this one is supposed to be what do we call it? Previous attack. That's too long. Prev attack. Prevat attack. And what we're gonna do here, when it rolls an attack, we're gonna compare it to whatever was the previous attack, and if it's the same one, we swap. But that just guarantees it just swaps between them, right? First does this, then this, then this, then this, and that's no good either. So what we're actually gonna do here is we're gonna have two of these registers, previous attack 1 and previous attack 2, and we're just gonna make sure it can't roll the same attack 3 times in a row. I think that's enough. It can do the same attack 2 times in a row, but not 3. I think that will be good enough. So let's see, now we need a at this point in the like sprites tables section, there's a lot of timers, we can't use those. Let's make sure we find something we can use here. Right here, I have the defines here. We can use this one, I guess. Sprite, no, we can't use that. What am I thinking? Here, this one, sprite, this is the one I was thinking about. Sprite misc C2. Like so. So here, when we roll a new attack, we get the previous attack 1, store that to previous attack 2. We get the attack that was just finished and store that to prev attack 1. And now when we roll the attack here, we compare to prev attack 1. If it's not the same, then this is fine. I guess we can just call this label fine. And we compare it to prev attack 2. If it's not the same, it's fine. And here, re-roll attack. We don't actually want to write any RNG code here, so I guess we shouldn't call this re-roll. We'll just increment it by 1. But this has a problem, which is that, as you can see, this is index 0, this is index 1. And if we're on 0 and we increment by 1, we get 1. Perfect, we use this one instead. But if we're already on 1 and we increment it by 1, we'll get 2. And there is no entry 2 here. So what we're gonna do is we add an end label, and we are going to compare here. Compare.b to make sure the assembler inserts it as a 1-byte code. And we compare to pointer end minus pointer, and we want to divide this by 2 to get the index value. If it's less than this, we just do nothing, otherwise we load 0. So this causes it to loop back to 0 here. And let's make let's make it, see if it works. So he falls down, so he rolled stand still. And now this should be a lot more consistent. So you see he will do an attack and he will do it 1 or 2 times, but he will never do it 3 times. You can see he doesn't run that far, he doesn't stand still for more than 2 seconds ever. So yeah, this is already way better. This is already way better RNG control. We're probably gonna keep the system the entire way through actually. I really like how this turns out. Let's see, he should be able to walk to here. Yeah. There you can see he walked about half the screen, then he turned back because he rolled Bum Rush twice in a row. Okay, awesome. I'm really happy with the structure of this so far. So we have all our defines up here. We have routine defines, RAM defines, sprite reg defines. We have this. Oh, I actually made this already. I guess I should put this here. Maybe I should put this up here in the data part. But different attacks might have very different speeds. I think this can stay here for now. We have the hitbox loader, we have the animation loader, we have the animations handler and graphics, which is just a time map loader right now. Whew, alright. I wonder, should we make anything else right now? I guess we can put a damaging hitbox in front of the sprite while it's bum rushing, and that will probably be like the last thing we do for now, because I'm getting very tired. I was supposed to stream earlier, but my neighbors were making so much noise that I had to put it off for a while. Let's see. So how do we make use of the hitbox loader? We probably want to make this a JSR-able routine instead of something that is just here. So let's see here. The hitbox data is supposed to be stored here. Test hitbox. Let's make something that we might actually end up using. We call this the attack box. I'm starting to be a little bit skeptical of like storing a bunch of data in the same label here. Maybe this should not be how we do things. It makes it easy to reuse hitboxes later, but I don't think we're gonna have a lot of hitboxes that are used multiple times. But we'll do this for now. We want this to be in front of the sprite, so we'll put this like offset -32, and we'll put this offset at like up 16 pixels, and we'll make it 2 blocks wide and I guess two blocks tall as well. We want to load this hitbox, and let's see here. Hitbox bounce code here. I'm actually gonna take all of this. Let's. Okay, I think I know what I'm gonna do. I'm gonna add a just generic interaction code here, and oh, okay, index with Y apparently. Data test hitbox. JSR hitbox. Let's see, what does that return? If we make this a JSR routine, it will go here. We do this stuff. Okay. Load hitbox apparently. So I guess we only go into index 16-bit. No contact. We'll do that, and we're gonna turn this into a JSR routine, like I said. And this is, yeah, here we go into 16-bit accumulator. Left, right, and let's see, here we're going to all regs 8-bit. And there we have it loaded. So we put the RTS here. And we just made this sort of JSR routines. We're gonna put it way down here where it's not in the way of anything. Let's just add a comment here that says like JSR routines below. Let's make a little like banner out of it so it's easy to see. So if you just scroll past this like real fast, you'll easily be able to see this. That looks right to me. Here. Bounce code. So we still have that. Awesome. This comment can go down here, I guess, if you want to keep it. And now we have made that a JSR routine. So now we go into this code here, and we just wrote that. We have to go into 16-bit Y, 16-bit index, and we load data. And we called this the attack hitbox, I think. Here. Okay. Capital H, of course. JSR hitbox. And now we want to see if this touches Mario. So I guess we just copy these. Oh. No contact label there. And then we just want to hurt Mario really if it touches, I guess. Sprites. How do you hurt Mario again? It's a subroutine, I know. This is not going to interact properly with Yoshi, I believe, but I don't think you can bring Yoshi to the final boss anyway. Hurt subroutine. JSL to it to hurt the player. So just copy this, and let's see here. Hurt Mario. Bank B. Hurt Mario. Wonderful. And that should do just fine. So while the boss, and keep in mind, hitboxes only last on the frame that you load them and process them. They don't last on their own. So while the boss is like running at you, we're also gonna make it slower to make it easy to see what's going on. That's too slow. They should be the same. While the boss is running, you get hurt if he runs into you. Let's also make one more change here. We're gonna make it so that the boss can only run while it's on the ground, I think. We're gonna add air, ground, and go to shared. Here, if it's in mid-air, let's just set X speed to 0. And later on, we'll probably write some fancy acceleration code. But for now, we're just gonna have this to make sure it works. Oh, that didn't go so well. Right, because in hitbox, there's no sublabel anymore. So I can't use sub-sublabels. Right and left and right X. That should do it. No, one more. Interaction, no contact redefined. So go to this label. See here. Oh, we actually do have. Oh, I see. We just have 2 of those. That's silly. Let's remake it. Awesome, it assembled properly. And let's see. If we're right, we should die if the boss runs into us. Alright, I made a hitbox. As you can see, I made the hitbox really big. You can also see something else. That was a bug I didn't realize was here. the hitboxes keep interacting with Mario even if Mario is actually dead already, so we're gonna add a little check for that. I think it's address 77. And that is Mario's animation. No, that's blocked status. What is it? 71. Player animation trigger 71. Let's add a define for that. Let's see. Let's add another one. Mario RAM. Mario anim, I guess. And it's 71. And in the we're here in interaction, no bounce timer. We're probably gonna split this. I don't want to make an aura check, so I'll just do this. Is gonna look scuffed, but it's fine. It's gonna make more sense later. Mario anim, BNE, no contact. Mario can only interact if he's in his normal state. And we're gonna add the same thing up here in the attack code. Let's see here. Attack and see here, hitbox shared. No contact. We make it again, and this time, yeah. So we can see, as you saw, I made the attack hitbox really big. It's 2x2 tiles, so I get hurt here. I also can't really safely jump on the boss while it's walking because it has this massive hitbox in front of it. So if let's see here, pain. If I'm correct about what I just did, the attack hitbox is something like this. You can barely see that. Can we get a good brush there? The attack hitbox is something like this. This is why we can't really jump on the boss while it's running at us. Whereas the bounceable hitbox, let's see here, the test hitbox, as you can see, it's -2. Why is it -2? It should be +2, shouldn't it? Yeah, this one should actually be +2. This one is here. This is the like bounceable hitbox, and as you can see, like there's a tiny part of it that is outside the like hurt hitbox, but like this is what we're working with right now. This is why we're getting the behavior we're getting. But I think these systems that we just made are gonna be they're gonna be good enough to carry us into the end game of this little project here. And we just hit an hour of stream time. Awesome, that's the goal I set for today. And we did make some progress. This isn't exactly looking like a final boss yet, but we're making some progress there, which is awesome. But that's gonna be about it for today. Tomorrow we are gonna make a diagram like Anon suggested, which is a very good idea. I think that's gonna make this structure make a lot more sense. I'm kind of just coding this in the way that I'm used to from working on Extra Mario World and a few other side projects I've had. But if you're only used to the like Super Mario World sprite paradigm, this is probably gonna look really weird to you. So next time we're gonna focus on making a diagram to make sure the structure makes sense, and we're probably gonna like if we get any questions, we'll take those as well. If anyone ever has any questions, just shoot them in the chat and I'll do my best to explain. But for now, that's it. Thank you everyone who watched, and I hope that this turns into a useful resource. Alright, thank you everyone, and goodbye.